It seems obvious. Long-necked dinosaurs were simply too big, too heavy to be lifted by a tornado. But maybe size isn't the problem, because the real question is, were their necks actually strong enough to survive one? And once you start thinking about it, the answer isn't as simple as you'd expect. Hello, and welcome to Oddology, a place where weird questions find real answers. First, let's talk about what we're actually dealing with. Long-necked dinosaurs are called sauropods. They lived from about 228 million years ago to 66 million years ago, from the late Triassic all the way to the end of the Cretaceous. And for millions of years, they were among the most successful animals on Earth. They reached their peak during the Jurassic period, around 163 to 145 million years ago. Now, when people imagine sauropods, they picture giants. And yes, some of them were absolutely massive. Take Argentinosaurus, over 30 meters long, and weighing somewhere between 60 to 80 tons. Or Brachiosaurus, which could reach heights of over 12 meters just by lifting its neck. That's like looking up at a living 4-story building. But here's something most people don't realize. Not all sauropods were giants. Some were much smaller. Species like Megarosaurus, only about 5 to 6 meters long, each and weighing roughly 1 ton, about the size of a large cow. These smaller species existed because of something called island dwarfism. When large animals are isolated on islands with limited food, they evolve to become smaller over generations. And this is where things get interesting. Because if a tornado can lift a 1-ton animal, then suddenly, some dinosaurs are no longer too big to be affected. So, let's do some physics. To lift a 1-ton animal off the ground, you need to overcome its weight. That's roughly 9,800 newtons. Now, if we estimate the surface area exposed to wind to be around 2 square meters, we can calculate the pressure difference needed. That comes out to about 4,900 pascals. Using the equation for dynamic air pressure, we can estimate the wind, the speed required, and the result is around 322 kilometers per hour. That's already within the range of an EF4 tornado, powerful enough to destroy buildings, flip cars, and tear structures apart. So in theory, yes, a tornado can lift something that weighs a ton, but reality is far more chaotic. Tornadoes don't just blow in one direction. They rotate, they shift, they create violent upward currents called updrafts. Objects caught inside aren't gently lifted, they're dragged, rolled, slammed, and sometimes violently thrown. So, how strong can tornadoes really get? Let's look at real-world examples. In 2011 in Oklahoma, an EF5 tornado struck an oil drilling rig called Cactus 117. This structure stood about 43 meters tall and was anchored to the ground with a force equivalent to 860 tons. That's roughly the weight of 10 Argentinosaurus combined. Engineers believed it could withstand extreme conditions. They were wrong. The tornado toppled it, rolled it, and completely destroyed it. Estimated wind speeds reached up to 475 kilometers per hour. And it gets even worse. In June 2025, a tornado swept through North Dakota. It derailed 33 freight train cars. Let's break that down. 19 grain cars, each weighing about 130 tons, were overturned. 14 empty oil tank cars, each weighing over 33 tons, were also flipped. And some of these cars were thrown as far, near as 145 meters away. Think about that. A 33-ton steel object launched across the landscape like it was nothing. Physics estimates suggest it takes around 370 kilometers per hour winds to flip a fully loaded grain car, and over 428 kilometers per hour to throw a 33-ton car that far. So now, put that into perspective. These train cars weigh tens to hundreds of tons, and they're low to the ground, and yet they still get flipped and thrown. So what about a sauropod? A creature weighing 30 to 70 tons, with a long neck extending high into the air. Yeah, that's not exactly stable, which means in a powerful enough tornado, even a giant dinosaur could be lifted, destabilized, or violently thrown. Now, let's talk about the neck, because that's the most vulnerable part. Could a sauropod's neck actually break? Short answer, yes. Tornadoes can snap large trees that are thick, dense, and deeply rooted. So a long, flexible neck has its limits. But here's something fascinating. Sauropod necks were actually highly optimized. Their vertebrae contained air-filled cavities, similar to modern birds. This made their necks lighter, more flexible, and structurally efficient. It also improved their breathing, because if they breathed like humans, air would have to travel through that entire long neck before reaching the lungs. That creates something called dead space, where air doesn't exchange oxygen efficiently. Instead, scientists believe sauropods had a bird-like air sac system. Air flows continuously, keeping oxygen moving through the lungs, even during exhalation. This system is, incredibly efficient. And it's one of the reasons they could grow so large. But even with all that, there are limits, and a violent tornado is far beyond those limits. So, could a sauropod survive a tornado? Maybe, if it's far enough away, if the winds are weaker, if it manages to stay grounded. But in a direct hit from a powerful tornado, it doesn't matter how big you are, you're not safe. And as for whether they would spin like a helicopter, yeah, we're not even going to try answering that one. And that's Oddology. What do you think? Would these giants stand their ground or take flight? Let me know in the comments. And don't forget to like and subscribe.